Now next topic is function. See, first of all we discussed Cartesian product, then we discussed relation. Now we are coming on function, third topic, function. To understand these words in definition, here I am taking one example. From example you will be able to understand these words very easily. So taking one example, let set A be the set of elements containing 1, 2, 3, 4 and B be the set of elements containing, suppose I am taking here different numbers, -1, 0, 5, 7. A has 4 elements, B has 4 elements. So A cross B has 16 elements. So number of subsets is 2 raised to 16, very large number. So we can form 2 raised to 16 relations. A has 4 elements, B has 4 elements, so A cross B has 16 elements. So total number of subsets of A cross B is 2 raised to 16. So total number of relations from A to B is 2 raised to 16. Very large number. So from this list of subsets or relations, we are discussing about few relations. Relation means subset of A cross B. Keep remember, A cross B has 4 into 4, 16 order pairs. Out of 16 order pairs, I am taking few order pairs. Let me take, I am taking first relation from A to B. Suppose I am taking a relation containing 1, -1, 2, 5, 3, 0, 4, 7. This is a relation from A to B. Here this relation I denote by F. It is a relation. Because it is a subset of A cross B. Because F is subset of A cross B. Now we check this relation in diagram. See, this is a Venn diagram. To understand in better way, I am putting this in Venn diagram. Set A contains 1, 2, 3, 4. Set B contains -1, 0, 5, 7. First set is A, second set is B. See, we can say image of 1 is -1. Image of 1 is -1. Image of 2 is 5. Image of 2 is 5. Image of 3 is 0. Image of 3 is 0. Image of 4 is 7. Here we say image of 1 is -1. Image of 2 is 5, etc. Now we are coming on this word. A relation from a set A to set B. This is a relation from set A to set B. It is said to be a function from A to B if every element of A has one and only one image in B. Every element of set A has one and only one image in B. So say, look here, image of 1 is only 1, minus 1. Image of 2 is 5. Image of 3 is 0. Image of 4 is 7. So every element has one and only one image. No any element has two images. So here this word is important. Every element of set A must have one and only one image. And here it is. 1 has image minus 1, 2 has image 5, 3 has image 0, 4 has image 7. Every element of set A has one and only one image in B. So this relation is a function from A to B. So F is a function from A to B. Here A is domain and B is codomain. A is domain, this set is domain, this is domain and this is codomain. Let us take second example. Suppose if I take, now see second example of relation on same set A to B. Suppose I take F equal to image of 1. First element I am taking from first set. Second element taking from second set. Image of 1 is minus 1. Image of 2 is 0. Image of 3 is, suppose image of 3 is 5. Image of 3 is 7. Image of 4 is 7. I am taking this relation. See, first element 1, 2, 3, 3, 4. 1, 2, 3, 3, 4. First element from first set. Second element minus 1, 0, 5, 7, 7. Minus 1, 0, 5, 7, 7. Second element from second set. So this is, it is a subset of A cross B. So it is a relation. It is a relation from A to B because F is subset of A cross B. Now let us check, is it a function? Is this relation is a function that we are checking? For which we have to check these conditions. So to check the condition, I am taking here Venn diagram. Set A, set B. A contains 1, 2, 3, 4. B contains minus 1, 0, 5, 7. Now see, image of 1 is minus 1. Image of 1 is minus 1. Image of 2 is 0. Image of 3 is 5. Again, image of 3 is also 7. Image of 4 is 7. So this is pictorial representation of this relation. We can say it's a Venn diagram. This is a relation F shown in this Venn diagram. Now let us check, is it a function? So we check condition. A relation from a set A to set B is said to be a function from A to B if every element of first set A has one and only one image in B. First condition, does every element of A have image? See, A has 4 elements, 1, 2, 3, 4. 1, 2, 3, 4. From every element, ray is coming out. From every element, ray is coming out, that means every element has image. Same thing you can see here. Every element must be in first place. See, every element is in first place. Here also you can see. Every element of first set has 4 elements. So, every element is in first place. 1 is in first place, 2 is also here in first place, 3 is also here in first place, 4 is also here in first place. So, every element must be in first place. Or in diagram, from every element ray is coming out. It means every element has image. Now second condition, how many images? 1 and only 1 image. See, only 1 arrow is coming. From every element only 1 arrow is coming. Now look here, from 3, 2 arrows are coming. Image of 1 is only 1, image of 2 is only 1, but there are 2 images of 3. Here, image of 3, here 3 belongs to A and 3 has 2 images, 5 and 7. Which is not allowed. There exists an element which has more than 1 images. If you find more than 1 arrows coming from any element, that means it has more than 1 images. That is not allowed. Condition is every element must have 1 and only 1 images. So these words, this condition is broken. So this relation is not a function. Here also you can see 3 has 2 images. So repetition of 3 in first place. There is a repetition. If repetition in first place, not allowed. So this is not a function. So every element, therefore every element of A has not unique image. So here F is not a function. So keep remember, to check whether given relation a function or not, always observe first place. No need to observe second place. Observe first place in given relations. What you have to observe? Every element must be in first place, but without repetition. If you find repetition, not allowed. If you find anything missing in first place from set A, it is not a function. So to be a given relation a function, check first place in that relation, first place in every element in that relation. In first place, every element must appear, every element of set A must appear without repetition. So these are examples to understand this definition. Now see, here A is a domain and B is codomain of function. Because this is a function, here A is domain and B is codomain. This was not a function. If domain is a subset of R or R itself, here say I have different symbol for R. This is set of real numbers. I have drawn here double line. So this symbol is for set of real numbers. If domain is subset of R or R itself, set of real numbers, then function is said to be a real function. Real function. And if range is subset of R or R itself, then function is said to be real valued function. So here, this is domain. Domain is subset of R, so it's a real function. Codomain, or if you observe here a range, what is range here? Range contains all numbers. Range contains -1, 0, 5, 7. So range is a subset of R. Range is a subset of R. So this is a real valued function. It's a real function as well as real valued function. Now we take more examples to clear in better way. Third example, we are discussing for same sets A and B. Suppose I am taking a relation f equal to, relation contains 1 minus 1, 2, 5, 3, 7. This is a subset of A cross B. So it is a relation because F is a subset of A cross B. Now we check Venn diagram. A, B, set A contains 1, 2, 3, 4. B contains -1, 0, 5, 7. Image of 1 is -1. Image of 2 is 5. Image of 3 is 7. This is the pictorial representation of this given relation. Now check, is it a function? So we verify these words. What is the condition? Every element of set A has one and only one image. See, image of 1 is -1. Image of 2 is 5. Image of 3 is 7. But 4 has no image. Here 4 is missing in first place. Say 1 is in first place, 2 is in first place, 3 is in first place, but 4 is missing in first place. No any element of first set should be missing in first place in given relation. And here it is. Means no ray is coming out from 4. So this is not a function. Here f is not a function because image of 4 does not exist, or 4 is missing in first place in given relation. So this is not a function, it's only relation. So remember, every relation is not a function. There are a few relations which are functions. Those relations satisfying this condition, that in that relation every element of first set must appear in first place without repetition. Let us take one more example. Suppose f equal to image of 1 is -1, image of 2 is 0, image of 3 is 0, image of 4 is 7. See, without diagram we can check in this relation. This is a relation. It is a relation. It is a relation from A to B because f is subset of A cross B. This is a relation from A to B, from A to B, because f is subset of A cross B. Few words I missed, so corrected this statement. Now is it a function? So check this relation. What is the condition? Every element of first set check in first place. See, 1 is here, 2 is here, 3 is here, 4 is here. Every element appears in first place and without repetition. So no repetition. Every element is visible in first place without repetition. So this is a function. So that's enough. Without diagram, without anything discussing anything from diagram, directly you can say whether it is a function or not. Check only first place. No need to check what is in second place. For any relation from A to B, check only first place. Every element of first set must be in first place without repetition. So this is a relation. Here f is a relation. F is a function from A to B because every element of set A is in first place in ordered pairs belonging to F without repetition. Every element of set A is in first place in ordered pairs belonging to F without repetition. No repetition in first place. So that's why this is a function. So if we check this in diagram, then here first set is 1, 2, 3, 4. Second set is -1, 0, 5, 7. Image of 1 is -1, image of 2 is 0, image of 3 is 0, image of 4 is 7. So in second set 5 is missed. If anything is missed in second set, allowed. But if anything is missed in first place, not allowed to be a function. Here this is not a function, here this is a function. Because both conditions are satisfied. From every element one and only one arrow is coming. From no any element 2 arrows coming, more arrows coming. From every element arrows are coming and one and only one arrow. That means in first place, observe only first place, every element of first set must be in first place without repetition. So this is a function. Now see, if f is a function, here image of 1 here image of 1 image of 1 under image of 1 under f is -1. This is denoted as image of 1 under f is -1. Image of 1 under f is -1, denoted as f of 1 is -1. Now we can also speak this statement by this way, that pre-image of -1 is 1. Pre-image -1 under f is 1. Pre-image of -1 is 1, image of 1 is -1. Image of 2, or we say image of 4, image of 4 under f is 7. Image of 4 under f is 7, means f of 4 is 7. This can also be spoken as pre-image of 7 under f is 4. So in this discussion here, if f is a function from a to b, image of x is y under f, then y is image of x under f, and set of all images is said to be range, and range of this function is range of function is set of all images. Fx is image where x belongs to A. So say here range is set of images. This is image, this is also image, this is not image, this is also image. So here range contains -1, 0 and 7, and it is also clear from this set -1, 0, 7. So this was about function. Now questions on function. A function f is defined by fx equal to 2x minus 5. Find values of f of 0, f of 7 and f of -3. Putting here x equal to 0, we get f of 0 is 2 into 0 minus 5, that is minus 5. So image of 0 under f is minus 5. Now to find f of 7, I am taking x equal to 7. Putting here 7, 2 into 7 minus 5. So 14 minus 9, 14 minus 5 is 9. So image of 7 under f is 9. Here image of 0 is minus 5. Then for f of minus 3, putting x equal to minus 3, f of minus 3, so we put here minus 3, 2 into minus 3 minus 5, so this is minus 11. So image of minus 3 under f is minus 11. See here, we speak these statements like this: image of minus 3 under f is minus 11, or pre-image of minus 11 under f is minus 3. Pre-image of minus 11 under f is minus 3. So such statements are spoken by this method. Now say in this question, fx is x cube. We want to find value of this expression. Expression contains f of minus 1, f of minus 2, f of 3. So putting here x equal to minus 1, so put here minus 1, minus 1 cube is minus 1. Putting here minus 2, f of minus 2 is minus 2 cube is minus 8. And putting 3, f of 3 is 3 cube, that is 27. So putting these values in this expression, f of minus 1 is minus 1, minus f of minus 2 is minus 8 upon f of 3 is 27. So plus 8 minus 1, 7 by 27. In this question, function t which maps temperature in degree Celsius to degree Fahrenheit defined by T of C equal to, here function is defined by T of C equal to 9C by 5 plus 32. Now first question, find T of 0. So here we have to put C equal to 0. So we are putting C equal to 0. Putting here C equal to 0, value is 9 into 0 by 5 plus 32. So it is 32. So 0 degree Celsius equal to 32 Fahrenheit. Function converts Celsius into Fahrenheit. The image is value of Fahrenheit. So this is image. It is Fahrenheit. Second, to find T of minus 10, we are putting, to find T of minus 10, we put C equal to minus 10. Putting here C equal to minus 10, so T of minus 10 is 9 into minus 10 upon 5 plus 32. So this is 5 into 2, 10. So minus 18 plus 32. Minus 18 plus 32, that is plus 14. So therefore T of minus 10 is 14. Minus 10 degree Celsius is equal to 14 degree Fahrenheit. So here whatever you keep here, same value put here, then calculate. So this is minus 18 plus 32, 14. Then third is find value of C when T of C is 212. Now we are putting T of C 212 in this formula. In this formula, we are putting T of C 212. So putting here 212, this is 9C by 5 plus 32. So this is 9C by 5 is 212 minus 32. So 9C by 5 is 212 minus 32, that is 180. That is C is 180 into 5 by 9. So 9 into 20, 180. So C is 100. So 100 degrees Celsius. It is equal to 212. This is Fahrenheit value.